Hello, I'm Lane. Let's talk about finding the range of a quadratic function. These problems look like this. They give you the quadratic function, and they ask you for the interval that is the range of that function. In my opinion, I would not follow this method that's shown in the explanation. I think I have a little bit of an easier way, but our goal is the same. We need to find the vertex of the parabola first. And then once we know where the vertex is, we can find this red line, which is the range of y values that the function covers. Let's look at one example. I'm going to copy this onto the blackboard. The general form of a quadratic function looks like this. Okay, a, b, and c are these coefficients. They're the numbers in this equation. And the x-coordinate of the vertex can be found with this expression. Negative b over 2a is going to be the x-coordinate of the vertex. So for our equation, what is b? B is 8, right? And a is the number in front of x squared, so a is 2. So if we plug those in, we're plugging in 8 for the b, and on the bottom we've got 2 times 2. So negative 8 divided by 4 is negative 2, right? So negative 2 is the x-coordinate of the vertex. The vertex is a point on the function. And that point will look like this, right? It'll have an x-coordinate of negative 2, and we don't know what the y-coordinate is yet. So let's find that. We can plug negative 2 into this function to find the y value of the function at negative 2. So let's work that out. G of negative 2 is going to tell us the y value at the vertex. Okay, so I just plugged in negative 2 for x, and in these problems, we cannot use the calculator, so we need to work this out by hand. So let's do that. First, exponents, right? Negative 2 squared is 4, so this is 2 times 4. And 8 times negative 2 is negative 16, right? And then we have plus 10 on the end. And 2 times 4 is 8. Now, 8 minus 16 is negative 8. And negative 8 plus 10 is positive 2. Okay, so this is the y value of the function when x is negative 2, and it's the y value of the vertex. So the vertex of our function is at negative 2, comma 2. So what is this parabola going to look like? Let me just sketch a graph. And where is the vertex? Negative 2, 2. Let's label our axes x and y. So negative 2 is going to be maybe right here for x, and positive 2 for y is maybe right here. So this is the vertex. I'm not putting the numbers on here. We just want to get an idea. Now, because the coefficient of the x squared, because a is positive, this parabola is opening up. All right, so if we graphed it, it might look something like this. All right, now just from this sketch, we can tell what the range is going to be. This parabola is going to contain y values starting and including at 2 and going to infinity, right? So from this point up, maybe I should do this in a different color. Okay, so from 2 on the y-axis and going up, everything on that blue line is part of the range of the function. And how would we write that as an interval? Well, we would start with the 2, and 2 is part of the range. It is a point on the function, so we use a square bracket with it. And the range extends to positive infinity, right? So let's go back over to Alex and we'll put this answer in. From 2 to infinity with a square bracket next to 2. Awesome, we got it right. Let's do another problem. All right, so the x-coordinate of the vertex is going to be at negative b over 2a. So what will that be? Let's see. Negative b is going to be negative 24. And 2 times a is 2 times negative 3. Now, 2 times negative 3 in the denominator, that's going to be negative 6, right? So negative 24 divided by negative 6 is, it's going to be positive. And what's 24 divided by 6? It's 4, right? So the x-coordinate of the vertex is 4. To find the y-coordinate, we plug 4 back into the function. So we need to find f of 4. 4 squared right here, that's going to be 16. So we have negative 3 times 16. 24 times 4, what is that? 96, okay. Now here on the front, what is negative 3 times 16? It's negative, and what is 16 times 3? It's going to be 48. So negative 48 plus 96 minus 51. All right, now 48 is half of 96, right? So negative 48 plus 96 is going to be positive 48. And 48 minus 51 is negative 3. So negative 3 is the y-coordinate of the vertex. So our vertex is going to be at 4, negative 3. Okay, we got the 4 for the x-coordinate using this expression. And we got negative 3 for the y-coordinate by plugging 4 back into the function. Now, all we need to do is make a quick sketch of the graph so that we can have an idea of where the range is. So 4, negative 3 is going to be maybe down here, right? So x is 4 and y is negative 3. All right, now is the parabola opening up or down? We look at the coefficient of x squared. Since it's negative, the parabola is opening down, so it's going to be something like this. And where is the range in this graph? Okay, the range is going to be the y values. So if you imagine that this graph was like squashed against the y-axis, where would it lie? It would start at the negative 3, and it would cover all of the y values from negative 3 down, okay? So to write the range using interval notation, we need to start with the bottom of that range, which is negative infinity. Negative infinity. And then we end with the top of the range. So the range ends at negative 3, right? And the range includes that point because negative 3 is a point on the function. So we use a square bracket on that end. All right, so negative infinity to negative 3 should be our range. Let's check that. Excellent. Let's do another problem. Okay, this one, I think we'll just work this out right here on top of the Alex window. This one doesn't look too tough. Okay, so we need to find the vertex, right? Which is a point x, y. And we need to start with the x value of the vertex. And we know that we can find that using this, negative b over 2a. So what is b for this function? B is going to be negative 6, and what is a? There's nothing written in front of the x squared, so a is 1, right? That's 1 times x squared. So let's plug those in. On the top, we're going to have the negative sign that's part of the expression here. And then b is actually -6. So on top, we have -6. And on the bottom, we have 2 times 1. So that is the same as +6 divided by 2, which is 3, right? So 3 is the x-coordinate of the vertex. And to find the y-coordinate, we plug 3 into the function. So let's write what is g of 3. Okay, we've got 3 squared, which is 9, minus 6 times 3, that's minus 18, plus 10. Now, 9 minus 18 is -9, right? And -9 plus 10 is 1. So the y value, or the y coordinate of the vertex is 1. And then, is this parabola going to open up or down? Well, because a here is positive, the parabola is opening up. So this parabola is going to cover y values starting at 1 and going up to infinity. So that's exactly what the interval for the range is. It's going to start at 1 and go up to infinity. All right, we got it right. Let's do another one. Okay, this one has some bigger numbers, so I think I'm going to need some more room to work it out. Let me copy it over to the blackboard. So here's our function, and we need to find the vertex. So what is the x value of the vertex? It's going to be at -b over 2a, right? Looking at this function, what is b? b is -20, and a is -2, right? So on the top here, we have -20, and on the bottom, we have 2 times -2. Okay, so -20 is +20. 2 times -2 is -4, right? And 20 divided by -4 is -5. So our vertex is going to have the x-coordinate -5. Now we need to find the y-coordinate of the vertex, and so to do that, we plug the x value of the vertex back into the function. Okay, and we have a little bit of arithmetic to do here. Let's start with the -5 squared. That's 25, right? What is -20 times -5? It's +100. So plus 100 minus 48. Okay, -2 times 25 is -50. And -50 plus 100 is going to be 50, right? So this is 50 minus 48, which is 2. So 2 is the y coordinate of the vertex. Now, because a, the number in front of x squared, is negative, this parabola is opening down. So that tells us that the range is going to start at -infinity, and it's going to end at the y value of the vertex, which is 2. So this is going to be our answer. And if we wanted to sketch a little graph, we could do that easily. Let's see, the x-coordinate of the vertex is -5, so -5, 2 is like right here. And because the number in front of the x squared is negative, we know this is opening down. And so the range is going to be everything from 2 down, or we write it, starting with the negative. So everything from -infinity up to 2 is our vertex. So let's go back over to Alex and we'll put that answer in. -infinity to 2. -infinity to 2. Okay. All right, let's do another example. Okay, so we start by finding the vertex. we know that its x-coordinate is going to be negative b over 2a. So what is b? B is 24, right? And a is 3. So negative b would be negative 24. And we have 2 times 3 on the bottom. 2 times 3 is 6, right? So negative 24 divided by 6 is negative 4. So we know that our vertex is going to have the x-coordinate negative 4. And we need to find the y-coordinate of the vertex. So we plug negative 4 into the function. Okay, negative 4 squared is positive 16. So 3 times 16 goes right here. What is 24 times 4? We worked that multiplication out in a previous example. It's 96, right? So this next term is actually going to be minus 96. And plus 44 on the end. Now 3 times 16, what is that? 48, right? And we know that 48 is half of 96, so 48 minus 96 is minus 48. Minus 48 plus 44 is negative 4. So the vertex is at negative 4, negative 4. Now, does this parabola open up or down? It opens up, right? Because the coefficient of x squared is positive. So the range is going to start at the y value of the vertex and it's going to go up. And we can also make a sketch of that. So the point negative 4 is going to be somewhere down here in quadrant 3. The parabola is opening up. That's not a very good parabola. It's kind of pointy, but the range of the function is going to be from negative 4 to infinity. So we would write that like this, bracket negative 4, comma, infinity, parenthesis. So let's go over to Alex and put that in. Awesome. I hope that this was helpful for you. Like I said, I think that method of using negative b over 2a is a little bit easier than doing this, completing the square that they show. It does involve a little bit more arithmetic, right? We have to do some more multiplication than I think would have been necessary in this example. But in my opinion, it's easier to remember negative b over 2a than to follow that process. So I hope that that was helpful for you. I'm going to put some links up here to other videos in this objective. Thank you very much for watching, and I hope you have a great day.